TensorFlow is a free and open-source software library for machine learning and artificial intelligence. It provides a wide range of tools and functions to help developers and researchers create and deploy machine learning models. TensorFlow was developed by the Google Brain team for internal Google use in research and production. The initial version was released under the Apache license 2.0 in 2015. Google released the updated version of TensorFlow, named TensorFlow 2.0, in September 2019. Deep learning algorithms have been used for several years across many products and areas at Google, such as search, translation, advertising, computer vision, and speech recognition. And TensorFlow is, in fact, a second-generation system for implementing and deploying deep neural networks at Google. TensorFlow can be used in a wide variety of programming languages, including Python, JavaScript, C++, and Java. This flexibility makes it useful for a range of applications in different sectors. Now the question is, what do tensor and flow stands for in TensorFlow? Tensors are the standard way of representing data in deep learning. Simply put, tensors are just multidimensional arrays, an extension of two-dimensional tables, matrices, to data with higher dimensionality. And flow means a data flow graph that is used in tensors computation. As we can see in this image, in this graph, nodes represent operations such as addition or multiplication, and edges represent data, tensors, flowing around the system. It's a typical data flow computation graph. Data in the form of tensors flows through a graph of computational operations that make up our deep neural networks. TensorFlow, in the most general terms, is a software framework for numerical computations based on data flow graphs. Basically, it is designed as an interface for expressing and implementing machine learning algorithms, particularly for the deep neural networks. It is important to note that TensorFlow was designed with portability in mind, enabling these computation graphs to be executed across a wide variety of environments and hardware platforms. It can be deployed for serving predictions on a dedicated server or on mobile device platforms such as Android or iOS, or Raspberry Pi single-board computers. TensorFlow is also compatible, of course, with Linux, macOS, and Windows operating systems. TensorFlow has several key features that make it a popular choice for building and training machine learning models. Flexibility. TensorFlow is a highly flexible framework that can be used to build a wide range of machine learning models, from simple linear models to complex deep neural networks. Scalability. TensorFlow is designed to scale from running on a single machine to running on distributed clusters of hundreds or thousands of machines. High-level APIs. TensorFlow provides high-level APIs, such as Keras, that make it easy to build and train machine learning models with just a few lines of code. Low-level control. TensorFlow also provides low-level APIs that give developers complete control over the computation graph and model parameters, allowing for highly customized models and optimizations. Data flow programming. TensorFlow uses a data flow programming model that allows developers to create complex computations by defining a directed graph of nodes and edges, representing mathematical operations and the flow of data between them. TensorBoard. TensorFlow provides a tool called TensorBoard that allows developers to visualize the computation graph, monitor the progress of training, and debug models. Cross-platform support. TensorFlow supports a wide range of platforms, including desktops, servers, mobile devices, and web browsers. Now the question is how one can learn it. If you are interested in learning TensorFlow, here are some steps you can take. Familiarize yourself with Python. TensorFlow is primarily a Python library, so it's important to have a good understanding of Python programming. There are many online resources for learning Python, including Codecademy, python.org, and learnpython.org. Learn the basics of machine learning before diving into TensorFlow. It's helpful to have a basic understanding of machine learning concepts, such as supervised and unsupervised learning, neural networks, and deep learning. There are many online courses and tutorials that can help you learn these concepts. Learn TensorFlow basics. Start by learning the basics of TensorFlow, including how to define and run computations using the TensorFlow API, how to define and train simple models, and how to use pre-built TensorFlow models. The TensorFlow website provides a comprehensive set of tutorials to help you get started. Practice with sample projects. Once you have learned the basics of TensorFlow, try building some sample projects to put your knowledge into practice. The TensorFlow website provides several sample projects that you can work on, such as image classification, text generation, and natural language processing. Join the TensorFlow community. There is a large and active community of developers working with TensorFlow, and joining this community can be a great way to learn more about the library, get help with specific problems, and stay up to date with the latest developments. You can join the TensorFlow community on GitHub, Stack Overflow, and the TensorFlow forums.